Okay, training motivation. So actually, this training is replicate our training delivery last year in cooperation with the Ministry of ICT in Indonesia. They have digital talent scholarship program, and we are offering our open run as a new topic at that year. And the proportion is 30% theory, 70% practical. So the some key points I would like to convey at this opening is Open Run is not a new technology. Okay, I repeat, Open Run is not a new. It's not about new technology. It is an industry approach on how to build the run, because previously everything is closed by single vendor login, we say. But now industry has a new approach, not a new technology, new approach on how to build the run. And then question come from especially from the industry practitioner, from the engineer. If you know, there is a lot of job role in cellular network, from network design, radio network optimization, from NOC, and so on and so on. They have curiosity, what will Open Run bring that affecting on their job role. We would like to let them know, actually managing run, ordinary run, with Open Run will be a similar job role, because we're still talking the same things in technical. So by this training, it's a kind of a beginner, not even intermediate on Open Run actually, but to give the awareness after the series of awareness, what is Open Run, what is the difference between the regular run, that I believe already delivered within past 2 Wednesday session in Aura. And also we try to align the misconception that already spread in the public, that usually here in Indonesia, they always talk about the split about RU, DU, and CU, and they relate this with, this is the actual Open Run should be. This is one misconception about Open Run, because talking RU, DU, and CU is just talking about run functional split that everybody can adopt, because this is the standard from 3GPP. Even non-Open Run vendor also adopt RU, DU, CU model. So this is one thing that we make clarification. And the second thing, by this training, we also give a clarification to the engineers, practitioners, that actually managing Open Run will be similar with their daily tasks. So we have the training subject is operation and maintenance run, in bracket Open Run. We will see how similar it is. So this is the training motivation, and this is the way we deliver. We have online trainer, we have online participants, and we have internet, we have VPN, we have Open Run end-to-end LTE network setup on our lab. Actually, this training model, we must thanks to the COVID-19 pandemic, because unless of the pandemic, maybe we will have it offline. But the situation gave us a lesson, a very good lesson learned, that by deliver this model, we can reach more participants from all the region. Okay, be prepared for the participants, especially that who has the remote access that I already shared. So this is our setup. We have actually cellular network is built up from simple 3 components, as simple as 1, 2, 3. Number 1 is UE, our handphone. Number 2 is RAN itself. Number 3 is core network. So by setting up end-to-end in the lab, we must have core network. Previously, core network is a very expensive network element that almost impossible we have in the lab. But now with the open network and openness that TIP promote, we have Magma Open Core. It is an open source core network that you can also install in your lab. We have Magma Core Network representing EPC of LTE. That is number 3. Then we slide to the left, number 2, RAN. RAN, we talk about Open RAN, and in this case, we use the system from Parallel Wireless. Parallel Wireless have their own specific design on it. Previously, on ordinary RAN, we have radio remote unit combined with baseband unit sitting on site, have transport connection to the core network with S1 connection. And it repeats for each of E node B or BTS. But here in Parallel Wireless, they have one unique network element they called SNG, HeadNet Gateway. But for the purpose of the training, we camouflage the naming for RAN aggregator. Vendor specific means, in this case, by Parallel Wireless. So the setup, we have antenna here, mini antenna in a closed chamber, goes to the radio unit. And actually this is integrated RRU and BPU. It's very compact. And then we have RAN aggregator by Parallel Wireless. And then we go to core network Magma. If you have knowledge or familiar enough with the LTE architecture, actually this is the same architecture. The cable here running from RU to antenna, in the real case, in the field, this is presented by jumper or coaxial cable. The signal radiated from this antenna, in the architecture, we call it as an air interface, goes to our UE or our handphone. Then the connection between BBU RAN aggregator goes to the core network. This is S1 connection in the architecture of LTE. And here in the cloud image, we have illustration. This is me as a trainer and also to represent you as participants that can access this RAN aggregator. So on this page, the takeaway is actually we are accessing this RAN aggregator, the device that manage all the RRU and BPU. Then from this device, we can do all the things on operation and maintenance, from checking the status, checking the inventory, checking what is wrong for our mitigation or troubleshooting. Okay. And this is the difference between architecture of ordinary LTE with the special design from Parallel Wireless. On ordinary architecture, every E node B has their own IP address run to the core network connected by S1 connection. And it is repeated for each of E node B. But in Parallel Wireless, this RAN aggregator providing virtual E node B, virtual connection, this device aggregating the connection into single S1 connection goes to the core network or Magma. So in this Magma core network or EPC just only need to recognize one single IP goes to the RAN aggregator. Okay, this is the hardware. This is just like an ordinary LED indicator, green, yellow, flashing. And this is about the status. And we have the video here. Yeah. Waiting for backhaul. Backhaul means the S1 connection runs to the core network. and then ready, booting up. And then now in service. In service means the radio unit is now transmitting through antenna. So, and now we are entering the practice session. In this chapter, usually I try to give a simple analogy to the participants. Actually, E not B or LTE BTS is just a machine like our computer. And now it is being more simple to understand, comparing E not B as an object similar with what we have as a computer, as a machine, because it is truly similar. E not B is a computer or special purpose computer actually. It has machine, type, operating system, and then it has resource like CPU, memory, storage, and so on. In terms of operation and maintenance of run and also open run, the subject of this resource, special purpose computer resource, is a subject to be monitored. So we have in the lab one single E not B, but you can imagine if you have a network having hundreds or thousands, you need to think about how to present all the data in a dashboard, in an aggregated monitoring. Then we will talk about how to grab the data, how to present in the dashboard, and so on. But first, we need to understand and get the sense with a single E not B monitoring first. Okay, so it's time to practice. And you are now have a welcome screen. Yeah, welcome to HNG, HeadNet Gateway. On my previous slide, which network element it is, whether it is core network, run controller, the E not B itself.
If I can remember it right, this is directly connecting to the aggregator.
Correct. So you are now entering to the aggregator, the one who will manage all the E not B within the network. Okay. So as I mentioned before, we will start to looking for E not B properties. E not B properties. And for the analogy, it's actually a special purpose computer that we can see the properties of the special purpose computer. Okay, you can run first comment, please, GM. View the type of machine. You can type show.
Okay.
Show resource
system.
Resource system.
System machine type.
System machine type, correct. And for everybody who is familiar with Linux, the way we type will be similar with the Linux command.
Okay. So
you can just enter. Yeah. What you can explain from here, JM?
So it's like a computer, right? It's like a 64-bit computer.
Yeah. What you can relate this information with the Open RAN topic? Any idea? Yeah. You can explain from here that the system machine is actually x86. Yes, this is the machine type. What is the relation with the topic of Open RAN? How will you explain to the participants?
What do you mean? How do I connect this to the Open RAN?
Yeah, we can connect this with the idea of disaggregation of software and hardware. We can compare with previous vendor login. Let's say from vendor A, they have BBU. It is a special computer with ASIC, application specific IC for their computing machine. But with Open Run, we can use generic machine based on Intel x86 processors. So at the very first comment, we can explain to them, we are now seeing the Open Run implementation because we can run on any machine with Intel processor, and it is, we call it COTS, commercial off the shelf. Means you can buy the server everywhere in the marketplace within your country, and we will talk about the specification like RAM, CPU, storage, and everything like ordinary computer. And then we can put the software of run to this computer and it will work. So this is the very first concept of Open Run. So this is the relationship here.
So it's essentially getting a server.
Yes, correct.
Computer, server machine.
Yeah.
Any
Previously,
server machine.
with non-Open Run vendor, maybe they have their own design of chipset or processors. But now in Open Run, we can use generic processors like Intel X based on Intel x86. Okay. Do you get the idea, GM? Sorry.
Pardon?
Yeah. Do you get the idea?
Yes. Yeah.
I mean, because this is an TOT, training of trainers, that everyone here will be a trainer for the community in the Philippines later on. We will need to explain comment by comment and relate this to the previous introduction of Open Run. Give them the sense,
to visualize it,
the context. What is the difference? So not only showing a command line interface with black screen and everything, but we will need to relate with the previous introduction that already given. Okay, comment number 2. Do you get the slide, GM?
Wait.
Yeah.
It's down. Okay, it downloads already. Wait.
No problem. You can start show.
Okay, so this is the CLI list, right? For the
Yes.
Inundo. So do I have to show it?
It will be good that you can show it side by side.
Wait. I'll just
So
share
everybody
the
can
whole
see. Yeah.
Okay, so I'm sharing the whole screen. So this would be.
Be careful not to show your chat or WhatsApp.
Yes, work. Of course.
Yeah, so comment number 2. Please show us the operating system. Okay, wait, stop, GM. So
Yes.
instead of completely typing, then you can just press your tab button on the keyboard. Press tab.
Tab.
Yes. Show. I mean show.
Show.
Show. Space. Press. RES tab.
LES.
RES. You would like to type resource, right? But I will show you how,
RES and then tab. Okay.
Yeah.
So it will autocomplete. Okay.
Correct. System, you can also type
sys and then okay.
So
and then system.
If this is a valid command, it will be autocomplete. But if it is invalid command, that it will not show. System tab.
So like this one, system tab.
Yeah.
Okay.
OS tab. OS name, yeah.
OS name. Sorry. Okay, so it's Linux, using a Linux system.
Okay, what you can explain to us?
So first we have the machine, the server. and then it's running on Linux.
As
So we
a
have the
operating
operating system. Yes. So Linux anyone can run, right?
Yes.
Regardless of vendor.
Yeah. Can you elaborate more your explanation by previous introduction? We assume that previous session will be Open Run introduction. So this second comment is actually give more emphasis on how open it is. Correct, JM?
Yes.
Yes, because number one, you can buy the machine everywhere.
Yes.
Number two, the operating system is Linux that you can also get anywhere. Correct?
Yes. And it is unlike the Microsoft Windows where you can buy it, but Linux you can get it for free.
Yes. Now everybody can start thinking to build their own run then, especially for the researcher. And for the engineers, it triggers the awareness to learn about open source software. Correct, JM?
Yeah.
Yeah, because previously, when you are an engineer from vendor X or vendor Z, then you will stick on their guideline book on how the syntax and everything, right?
Yes.
But now we are entering the gate of open network or open run. You see, you can live in one vendor working there for 10 years maybe with syntax that you are familiar already. But in the era of Open Run, you need to be ready for, let's say, parallel wireless command, by cells command, Mavenir commands, and we don't have more space on our brain to remember, right, Jam? So the thing we need to do is be familiar with open source syntax, open source logic, and everything. It will help us to adapt faster. Okay, that's the way we elaborate with these two comments. Yeah. Okay, please continue, GM.
Okay. So we need to view the version, right?
Yeah. Tab. Yeah.
Tab.
Show.
Show resource. Sorry. Show. Tab.
Yes.
System. Tab. System. Tab. OS release.
Yeah.
Okay.
So this is the release from
of the release.
Yes. And we talk about one inode B, single entity. You need to give them context as an operation and maintenance engineer. They will not only manage one inode B, correct, GM? They will manage maybe 10, hundreds, or thousand.
Wow,
yeah. The ability to.
But for this setup, we only have one.
Yes. But we need to give them the context. In the real life, you will manage tens, hundreds, maybe thousands of network elements. Then you need to be aware to acquire skill of grabbing the data for multiple network elements. This is another topic, another technique. Okay, next, yeah. Okay, one thing I need to remind all of us as a trainer, this practical session will be very risky on the vibe or atmosphere in the training room, especially when it is online, because it is just typing the command and everybody practicing, and the room will be so silent. Correct, Jeff?
Yes.
That's why the method is, please try to give the participants an opportunity or chance to show their screen. Let them to run the command. Make a conversation with them. Okay, one participant, let's say 5 minutes, and then thank you very much. Now, can I have participants B to show? And then you maybe from 12 participants in the class, you can make a sampling of 5 participants and make the training more interactive. Okay. So what's next, GM?
So it wants us to show the system hours. So system. Uh, okay, sys clock.
Yeah.
Okay, so it's showing us July 27.
Yeah.
But it's 12:42. Right?
Yeah. So now what's next?
Okay, so we need to display the aggregator run system. So show resource and then system.
Yeah. If you remember, GM, previously, you always type show resource system, blah, 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 show resource system, blah, blah, blah. But by only typing show resource system,
Okay.
you
So
grab
you
it
get
all.
everything.
Yes.
So it's the entire profile of the machine, the server. Okay.
The suffix, I mean, show resource system, blah, 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 means you query the information for specific information. But when you type show resource system, you get it all, right? Yeah. Okay. So what's next?
Okay. Show resource system. Okay. So you need to view eNodeB system. So let's type show tab access tab nodes.
Yeah.
CWS tab okay.
No problem. CWS space.
Okay. CWS space resource tab, system tab, and then.
Okay, stop. If you remember, GM, we have Magma Core Network, and you have welcome screen. Welcome to SNG. You already understand this is run aggregator, but now we have new terms here, CWS.
Okay.
Yeah, CWS is a parallel wireless term to call their eNodeB. Okay, so CWS is eNodeB. Now you are accessing the eNodeB, GM.
Okay.
Yeah.
So this is a different machine.
Different machine.
Okay.
So one run aggregator can manage multiple eNodeB or multiple CWS. CWS is a specific terms on parallel wireless.
So if we have 5, so it'll be showing 5.
If we have 5, then we need to specify the name of CWS.
Okay.
Okay. But so far we have only
one.
Only one. And what you can explain to the participants here?
So it's using the same operating system.
Okay.
Okay. But then the machine type is, the architecture is using ARM.
Yeah. Now, everybody that have interesting on electronics, on hardware engineering, they can start opening their eyes also. Actually, eNodeB or BTS is built also with ARM. So actually, it is the same logic with computer, right, GM? It has operating system, it has software release, it has processor or machine type. Okay, next.
Okay, so showing run aggregator CPU usage. So show tab resource tab CPU.
Yes. Okay. It is like what happened to my computer in the beginning of this training.
it eats up a lot of resource.
Yes, it gets crashed. You now get the sense that run aggregator is actually somehow like a server of multiple eNodeB, right? The higher the load, then it will get higher load on CPU, and at certain level, how we manage this is actually can be a setting the alarm trigger for certain CPU level. It is possible, but not for this topic. But now at least we can see how to check the CPU. So we can again understanding this actually like we manage ordinary computer by seeing the CPU load. Because when CPU load is already high, maybe we can find a malfunction on the network element. Like we also have the similar problem on our computer. So we need to deliver this sense, the simplicity of understanding this like just an ordinary machine like we have in daily routine. So actually like this, the main idea is so far topic from 3G to 4G, 4G to 5G, from run to open run, we always thinking it's about a very sophisticated technology, right, GM? And it makes the participants afraid. But if we bring them this way, this is not very complicated to understand. It's like you already understand with your machine, then we can enter the mind map of the participants with a easier way. That's the idea, GM, how to deliver this.
Yes.
Yeah. Okay, so run aggregator has a CPU, and so does the eNodeP. Can you show us how to show the eNodeP CPU usage?
Okay, so
Command line number 8.
show tab access nodes. Okay. CW. Okay, so it's pointing to the CWS.
Correct.
CPU resource tab and then CP. So it's the same resource CPU, but pointing to the
eNodeP.
yes. Okay, CPU.
So, okay, what's the meaning
CPU.
of all of this information? We need to refer to the manual book of parallel bus. Okay. It has 3 CPU,
It has
CPU
less scores.
Yeah.
Cores.
When it is in a real life, the load will be higher, especially when the traffic is getting high. Okay, what you can tell us from command line number 10 before running the command?
Command line
before running the command, what you can tell us about running about CLA number 10?
It's showing the resource disk. I mean, it's the storage, the hard disk.
Yeah.
Usage. So how many? It's like a computer wherein we're checking if we're having still storage space.
Yes.
For saving, for storage, for other files.
Yeah.
So it would be a red flag if it's having high usage, meaning we don't have any more storage space.
Yeah. So no, we can expect the participant is now getting closer with the topic rather than the participant thinking about a very sophisticated technology, right?
Yeah. So it's like their own computer at home.
Correct.
Okay. So would you like me to run it?
Yes, please.
Okay. So show tab. Okay. So we just check first the aggregator disk. Show resource disk.
Yeah.
So you can also see the directory.
Correct.
And how many.
And the directory
available and then the percentage. Okay.
Yeah, and the directory structure is similar with your Linux operating system because it is built from Linux, right?
Yes.
So again, you can emphasize the importance of having skill on Linux to the participants.
Regardless of vendor.
Yeah. Okay, then you can also develop the conversation like this, Jam, especially when the participant is coming from operators or from NOC engineer. What you can consider by seeing this information is, let's say, if the storage is now almost full, then you can suggest this as an upgrade or maybe to balancing to the other node B. And then you can play with this data, especially when this data is coming with thousands or hundreds of node B. You can play with the data summary. You can fit this as a data to the planning department, right? Boss from 1,000 of our node B, 30% of it already have storage occupation 80%. We need to consider two, whether to upgrade the system, whether to swap the system with the newer, or whether to make a new set to the balancer. So yes, this is a very basic comment, but it means a lot if we know the significance. Yeah, okay. This is just idea to attract the attention from the participants based on their background, yeah, GM.
But in terms of planning, because I'm seeing it's not more than 1 GB of disk. So is it enough for expansion or anything for this aggregator?
Yeah. So actually it will be depends with the design and with the specification of the server. Yeah. And this is the data you need to have when you talk to the vendors or to the system integrators if you are acting as a MNO or operators.
Yeah. Because if, for example, some participants coming from MNO, they would be thinking of commercial issues like when you have expansion in the future and we already used up all the disk. So if we expand, it means downtime for this, right?
Yeah.
We have to switch or we have to expand. So it's better to what do you call this? To dimension. For future, yeah.
Or
so
you can use this as an initial assessment before buying, right?
Yes.
Yeah.
Because you don't want to use up too much that would cost, and not little, but you don't have you can't expand in the future.
Okay. Correct.
So this is a new one because MNOs are accustomed to dimension based from the vendor, how many like this and that, and then this is a different thing. But this is, I think this would be simple because it's a machine. I mean, everyone who knows computer would know how to. Yeah.
They can talk in the same sense, like they consider on computer, right? Okay. Next, you can jump.
So no need to check the because 10 would be showing the access nodes.
Oh yeah.
CWS resource disk. Oh, sorry.
Tab resource.
Sorry, resource, because disk. Huh?
Show.
Sorry, wrong spelling. Okay.
Yeah. 13%. 13. Yeah. Sorry. 582 available 497. Use 13. So it is only occupied for now around 20%, yeah, less than 20%. Okay.
Okay. So
now we are understand that we have network element called run aggregator. We have network element called inode B, and both of network element is actually a special purpose computer. It has run, CPU, storage, and so on, that we can monitor this in terms of operation and maintenance job role. But please remember, this is a solution by parallel wireless. In different open RAN vendors, they might not have this RAN aggregator network element. GM. But still,
but still,
still, the logic is same. Inode B will have machine type, operating system, CPU, storage, and so on. Okay. Then you can jump now to the command line number 14.
Okay. Because these are all information, just memory, memory status, they're all information. So we go to 14, show access nodes, CWS. So we're pointing to cell operational data.
Yeah. What you can expect from this?
So you have the BTA or the inode bin name, I think, right? So this is user defined, and then you can all now see the PCI.
Yeah.
And then you have now the ECI. So it's like a vendor GUI, but you are now in a different format, but still essentially getting all the run information. Cell reference signal power. Is this in DBM?
Yeah.
Okay. And then, okay, so it's running. So I'm assuming it's in green.
Green.
Yes.
Correct.
So it's functional there. Yeah. Somewhere there.
So somehow a simple image of the inode B itself, like I showed you in the previous slide, is useful. Then you can correlate with the LED color, right?
Yes.
Okay, next. Number 15.
So line 15 show running config access nodes CWS LTE cell. Okay.
Yeah. What information?
Port number. Oh, so you have the TAC now here.
Yeah.
And then you set a maximum subscribers.
So the port number, you have 2 port.
Okay, the port number is 2 port. Transmitting 1 and 2. Okay.
Yeah.
Operator QCI. And then okay, so you're using 10 megahertz here. And at band B8. So
B8 means
is what is B8? I forgot.
900.
Okay, 900.
900 megahertz.
Okay.
So it's
10 megahertz,
900 megahertz.
LA100. And then everything is in default.
Yeah.
Okay, so you have other parameters here. Newton cell reselection. So they're on default. And then the admin state is
enabled. Yes.
Okay.
So this is the very basic.
So here you're showing the operational state, and then here's the admin state.
Correct.
So yeah, okay.
So okay, what do you get from these 15 comments, JM?
This one it's like if for working in a telco, we're accustomed with the GUIs of different vendors, and they have different presentations. But it seems that with this in Open Run, it seems that we're getting the same information, but they are in a simplified forms. And I think regardless of what you're using, you're getting the same formats.
Yeah.
And regardless of your background before in terms of vendor wise, you won't have problem migrating different MNOs or different vendors, because if you know your basic RAN, like for me, this is my first time to seeing this aggregator.
Yeah.
But I already have, when I showed the cell information, I already know my PCI.
Yes.
Already know the power, the port, and then everything, and then the frequency.
Yes.
Operating frequency that you've been using. So you now have basic information on that BTS or on that inode.
Yeah. So here you can also convince to the participants with engineering background in telco, like I said in my opening, Open RAN is not a new technology. It is just an industry approach how to build the RAN. So actually the rest will be the same, right?
Yes,
Jim?
yes, yes.
Yeah. You can directly get attached and comfortable on accepting this knowledge because you already know it. Because like I said, this is not a new technology. What you have before as your basic knowledge also will be here. Because when we talk about RAN, about 4G, you will also talk about what is the PCR, what is the tag, what is the bandwidth and everything. And it is all the same. Okay, so another key takeaway from this slide you can convey to the participants in relation with Open RAN. On which part you see the openness from this slide?
From this,
on machine, on operating system, or anything, you get the takeaway.
My takeaway here is you can set up your network using out of the shelf machine.
Correct.
Yeah. So, for example, I'm an MNO. I want to set up my new network. I don't have to consider what vendor to buy. I just ask the engineering to purchase a common computer with Linux. So yeah.
And the story will be different when you talk to the decision maker participants, right? When
okay, there's a different lot.
Yeah. Planning department, maybe that you can.
So it would be cheaper, maybe, right?
Yeah, should be because
there are premium price. The price premium is because of the vendor specific considerations. Yeah.
Yes.
But in terms of this, I can go to maybe have a PO on a computer shop or a computer company to purchase these machines with Linux already in the system.
Yeah. And if you are from, let's say, an operator or a company that have so much money, they don't want to be hesitant thinking all of the things, but at least they know how to structure the pricing of the PO for negotiation, right? Because they know actually this is built from off the shelf machine, and so on and so on. And also when you talk to the new greenfield operators, we can also encourage them. Actually, you can choose from the server from which brand. You can mix and match, and also from different background like solution architect, let's say. Then you can compare Open RAN vendors that have software maturity level on RAN, because if you find a vendors of Open RAN that can provide the software only, then you can think about to have your own servers, your own specification. And maybe if you work with the existing company that already have data center as their main core business, like the case of Rakuten, right? We have very big server, let's say. We can utilize this as a baseband processing. Then you can only find an Open RAN vendor that provide the software of baseband unit and asking them about the functional split they use, the interoperability, and then you can go to another vendor of RU to negotiate the price of radio unit. So you can purchase everything from different place. Or if you like, you can just assign one system integrators to make the ingredients for you. So let's say the radio unit I will use from vendor X, the run software from vendor B, the server or the data centers from vendor C. So you can bring this basic information, this CLM monitoring as a wrapped up information, depends on your participants' background. It will be a different story when you talk to the student at the university, to the researcher, to the MNO, to the decision maker, and to the government. To the government, you can also talk about, we can now start thinking of building this as a national local product. And then we can imagine all around the Philippines nationwide how many cannot be on current status. We don't have any local component in there. By thinking of this, at least we can start thinking of some percent of the network element is made in Philippines or composed by Philippines community, and then we can claim this as a national product. So from 5G Philippines rollout, Philippines local community can produce local content or local component of the Philippines in 5G technology. Because so far we can only buy the solution and just only thinking 5G is sophisticated and advanced technology, we cannot afford to do this. So you can go with that narration when your participants is from government background or policy background. So actually, this slide is just an ordinary slide, like not just another slide like you get from another training, right, Jim? Yeah. But your insight on it, how to deliver this to the different background of participants, makes this slide alive, and the session will be alive in the training group. So that's the idea how to deliver this training here.